All right. So, chapter 14 examples. I don't know why this is like this.
Is that this Friday?
Yeah. Why is this doing this?
I thought we already had all of the gates covered.
We do. We just didn't write them.
Yeah.
It's getting a little bit better, but not by much.
Whoa.
Okay. If it gets out of focus, just let me know. It's been kind of out of focus today, so we're just gonna roll with it and see what happens. All right. So the law of large numbers was what?
I don't remember.
Oh,
Numbers can be large. I don't know.
As the number
Is it recording?
of independent trials increases, the long-run relative frequency of repeated events approaches a single value. Yeah.
As the number
I have.
of trials of a random event increases,
Can you turn the light off? Or is it just so focused?
It is
Never mind.
It's yeah.
I'm sorry.
oh, now you can actually see my hand up there. That's really weird. Normally y'all can't see my hand because it like is so bright.
No, we're just gonna focus on you.
All right, as the number of trials of random event increases, the difference between what we expect to see and what we actually see approaches a single value. Or well, technically in this case it approaches 0 because it's the difference between. So, but Maddie, also what you said is another like fine way to put it. So. All right, so commercial airplanes have an excellent safety record. Nevertheless, there are crashes occasionally with the loss of many lives. In the weeks following a crash, airlines often report a drop in the number of passengers, probably because people are afraid to risk flying. A travel agent suggests that since the law of averages makes it highly unlikely to have 2 plane crashes within a few weeks of each other, flying soon after a crash is the safest time. What do you think?
No, isn't there that thingy
I
about
think-
just because like it hasn't happened in a while means it like I don't know. I just want to say no. I don't like
Causation
flying.
is not equal to correlation.
Okay. Yeah. So essentially, it's not. One thing is, yes, it. Just because something hasn't happened in a while doesn't mean it's likely to happen, and vice versa. I'm glad Melcher has a name tag on. Or just because something has happened doesn't mean that it's not going to happen again for a while. That's not relevant. However, there is no such thing as the law of averages.
Oh.
Well,
That's funny. I knew it was one of those causation, equal things. It just doesn't exist.
They're
personally.
misusing the law of large numbers. And the law of large numbers only applies to a large number of trials, long term, not short term. So if the airline industry proudly announces that it has set a new record for the longest period of safe flights, would you be reluctant to fly? Are the airlines due to have a crash?
No, because the thing I said earlier. Just because it hasn't happened in a while doesn't mean it should happen.
Exactly. So, one other thing about it is that probability is independent. So one plane not crashing does not affect another plane crashing or not crashing. Okay? So probability is independent. So one plane not crashing does not affect the probability of another plane crashing Okay, and that basically is just another fancier kind of way of saying that something's not just due to happen because it hasn't happened in a while.
It kind of reminds me of like, there's this thing and you're trying to guess like odd or even. And if there's like a bunch of evens in a row, you really want to guess odd because you can't think even can be like 5 times in a row. But then even might be 6 seconds.
Well, that was like last night. Did any of y'all watch the football game last night, like the late game?
Was it the
Chiefs
Chiefs?
one?
Yeah. Did you watch the coin toss or the overtime coin toss? Did y'all see that? So it was funny because we were talking about like, I think in the playoffs, personally, it's a little bit unfair that it's just like if the first team that gets the ball scores, then the game's over. Like, it's the playoffs. I feel like both teams should have an opportunity to possess the ball, personally. But whatever, that's not how it works, so I can't change that. What does my opinion matter? But it was funny because I don't remember what the guy chose. I think he chose tails, actually. And then Kenny says, did you know it's actually more likely that it'll land on tails than it'll land on heads? And I said, what? He's like, because it's that side of the coin is heavier, so it's actually more likely for it to land tails, or because of the weight of the coin, the way that it's like dispersed, it's not even. And I was like, well, maybe on a real quarter, but they weren't using a real quarter. They were using like a special like football coin or whatever their coin was beforehand. Because I'm like, in volleyball, when you go up to the thing, they're not giving you, I mean, it's the coin's not typically a quarter.
Yeah.
It's, or like a $50.
It's
It's
like
usually like a ref's coin, which is like a ball and a ribbon or a
Yeah.
ball and a net or something like that. And so you're not actually calling heads or tails. Anyways, I just thought that was interesting. If there's 2 possibilities, they are equally likely of occurring. So there can't be... Now, the person could toss it a funny way, I guess, and figure out how to toss it so that it perfectly lands every time.
I want to learn that trick.
I don't even know if it's possible, but I'm just saying. It's not like... That's why I also think it's a little bit crazy that they call it before they flip the coin, but whatever. That's another beside the point. I think you should call it what's in the air. Anyways... All that to say, I'm going to get on a high horse about football, but all I'm saying is just because it lands tails most of the time doesn't mean it's guaranteed to land tails the next time and all of that.
All last week.
Random fun note about that. All right. So, many stores run secret sales. Shoppers receive a scratch-off ticket at the checkout to determine their discount. The store is required to reveal the distribution of discounts available. Which of these probability assignments are legitimate?
C. I think it's what?
A, B, or C?
B.
And actually, hold on. There's supposed to be one more. Let me add on one more. It might be multiple of them.
I think it's B.
Don't know. Actually, might be B.
B or D? Well, B, D.
It's D.
D.
D adds up to 100.
Exactly. Okay. 1, you can't have a negative.
No.
So C doesn't make sense. They have to add up to 1 because they're decimals. Okay. So you got to have that. So, okay. I could have been trying to trick you. But anyways, so that being said, you've got across in the A column, that adds up to 0.8. So that's less than 1. So that one's a no. The next one adds up to 1.1 all the way across, which is greater than 1. So that's a no. This one has a negative probability. So
No.
that's a no. Last one is equal to 1. So that's a yes. And just as a refresher for you, 0 means that it can't happen. Probability has to be between 0 and 1, and if it's 1, it must happen. That's the end of that one, so once y'all have all that.
Candy games ever like make you breathe weird?
They make the inside of my mouth feel weird.
Like, it feels like the breath that I'm breathing right now is like super skinny. Yes.
If that's the case, then you might be allergic to that. You might want to stop eating that.
No. It's not like
Like
that.
in your throat, like it like kind of feels a little tighter. Like
It's
your
like
heart.
colder.
Yeah, your heart's like tight.
Like, like when I breathe, it feels like.
You have myocarditis or something?
I don't know what that word is, to be honest.
It's an inflammation of the heart.
Oh,
Does
no.
your heart feel like humming?
I mean, people always tell me I have a big heart.
Oh
so.
my No.
Love that. Maddie's got a big heart, so she's got myocarditis.
No, that was so bad.
Oh my goodness. Anybody that watches these videos has to think we're crazy.
Yeah,
And there are people not from this school that watch these videos.
They're gonna think I'm a bad kid because the one time I was talking to Taylor.
Yeah. I wonder if they know what we're talking about.
We're talking about
Don't.
SUVs.
Well, at that time we were.
Was it Quinky D?
Just say it like that.
All right. In a large introductory to statistics lecture hall, the professor reports that 55% of students enrolled have never taken calculus. 32% have taken only one semester of calculus, and the rest have taken at least 2 semesters of calculus. What is the probability that you choose a partner who has studied 2 or more semesters of calculus?
You'd be very lucky.
So you have to do subtraction, right?
Okay. Subtraction of what?
You're adding 55 and 32 together, and then you're gonna subtract them by 100.
Subtract it from 100.
Same thing.
It's not.
And then you're gonna get an answer that I don't know off the top of my head. So someone who's smarter than me go.
It's like 23.
You're gonna get 13, and then
13.
is that it? Or do
That's
you
all
have
you need for that one.
Okay.
Oh, why did I put 23%?
Because Melcher said it. Melcher can't add
Well,
or
I
subtract, apparently.
I looked up and I just said the first number I thought was right. Cause
Just
I
a little bit off.
I saw 8 and 7 and I was like 23.
What is that?
All right, the next one. Probability that you choose a partner who has studied some calculus, okay? Now, some calculus means 1 or more semesters.
So then you would do 100 minus 55, which is 45%. I think.
What'd you say? How'd you get that? Can you repeat that?
I said 100 minus 55 because everyone else has done calculus.
Okay.
So
We're essentially using the complement rule.
yeah.
Wait, why is it just 1? Okay.
Well, I was going to do 1 minus 0.55, which, because of the percentages, but I'll just, yeah, I don't know. We'll just go back to
I
that.
was really confused. I was like, wait a minute.
Yeah, because aren't you not supposed to have percents?
I mean, it doesn't matter for this.
No more than one semester.
Okay, so another way you can do it is to look at the people that have had 1 or have had more than 1, and you can add them together. Just another way you could do the same, get the same answer. No more than one semester of calculus. So that means they've taken how many, possibly?
One or less.
One or less, so they've had 0 or 1. So how would we find that?
55 plus 32.
55 plus 32. So
No,
that's...
there's no minus 300. 300. 100.
87%.
That's a lot of people.
I can't believe you.
All right, so... What's happening? Hello. All right, probability of repeated events. So if two events, A and B, are independent, meaning that the outcome of A does not change the probability of B, then the probability of both occurring is the probability of A union B, or we could also write this as the probability of A or B, which is equal to the probability of A plus the probability of B. Okay, so again, this is because they are independent. In chapter 15 notes, you saw what happens when they're not independent. Okay, you saw that the formula changes in that situation. So, for them to be independent, then when we do it, we just add the two numbers together. And then 4 is a continuation of 3, so chalk it all that down and we'll pick it up. All right, so you are assigned to be part of a group of 3 students from the intro stats class described in exercise 3. What is the probability that of your other 2 group mates, neither has studied calculus?
You'd be upset.
So you see, is this where we divide?
We don't divide.
Okay,
What
so-
is division's buddy?
Multiplication.
So you're doing 200%, right?
No.
Oh.
So we need that neither has studied calculus. Yes.
Why does it say stats class
Why
and
does it say
calculus
stats?
class?
Because this question said in an introductory stats class, the professor reports that
Okay,
55% have
I
never
was
enrolled.
confused 'cause that had something to do with the thing.
So 55% of students enrolled have never taken calculus. So this question says the probability that neither has studied calculus. We're going to do 0.55 times 0.55 to figure out what the chances are that they have not done calculus.
How would that work?
1. I lied.
Because that's the probability that they haven't done calculus. Because we're taking the probability for each one not having done it. They're independent of each other. One student doesn't affect the other one. And then we multiply that.
75.
I tried to put that long one here.
It's, I don't know.
30.25%.
I figured it out for one thing and then I couldn't get it back.
Oh yeah,
I did it like
it is.
once and then I could never do it again.
Like I didn't figure out, I couldn't tell.
Like I know how to do it, but I can't like.
I need to try it, but I forgot about whole 5.
All right. And then that both have studied at least one semester of calculus, meaning they could have done one semester or they could have done 2 or more. So what was the percentage that we had from part 3 for that they had had some calculus?
45.
45. Okay, so that both have studied at least one semester of calculus is going to be 0.44 or 0.45. Why am I saying 44? Times 0.45 is equal to 20.25%.
Okay, using my brain, I think the next one is gonna.
The next one is a chicken foot.
What does that mean?
Is it the tree?
No.
The weird tree diagram?
Chicken.
I didn't
Oh.
like drawing that, even in it when it was right in front of my
I
face.
don't understand. Why is it called a tree if it looks nothing like a tree?
It does kind of if you turn it sideways.
Yeah, but you shouldn't have to turn it sideways to figure out what it is.
It looks like a chicken foot.
It looks bad.
All right, so what we're going to have is at least one has had more than one semester of calculus. So we're going to,
We don't have enough room for that.
well, write small.
That's why you don't use it on your iPad, guys.
Sucks to write on your iPad.
No, I can blow it up.
I
I'm
have so much room.
Yeah.
Oh, look at how much room I have. Look at
how
this.
much room we
Look at how
have.
much room I have to write. Wow. Isn't it great? And we don't even need to worry
My
about
pencils
changing
don't run out of
colors.
battery.
Exactly. I don't need to charge my pencil.
At my video. Oops. It was so bad. All right, so the top branch is going to be 2 plus. Bottom branch is 0 or 1. Ah! Undo.
Oh no.
0 or 1. Then 2 plus 0 or 1. 2 plus 0 or 1.
How do you know what is supposed to go on what?
Because I'm seeing what all my possible options are.
Okay.
Because in reality, at least one has had more than one semester of calculus. That means that one of them has had at least 2. So the first set of branches is that one person has had 0, like none or 1. The top branch is that one person has had 2 plus. Okay? So your person 1 has had one of those options. Then depending which route you go, okay, if your person 1 only had 0 or 1, then you have off of that person 2 had either 0 or 1 or 2 plus. If your person 1 had 2 plus, then your person 2 has either 0 or 1 or 2 plus.
It's getting kind of
It'll make more sense in a second.
Yeah, my brain's chugging.
All right, so so the probability of getting 2 plus or having 2 plus was what?
50%. No.
Part A from number 3.
13.
13%. So 13% and 13%. So it's going to be 0.13 times 0.13. 2 plus was 0.13. 0 or 1 was what?
20. No?
Part C.
87.
0.87. And then the next one, I'm going to have 0.87 and 0.13. Then I'm going to have 0.87 and 0.87. So I have 2 options here of how I can go about this. So I'm going to show you both. Okay. At least one has had more than one semester of calculus. Meaning, I've got to have one person that has 2, right?
Yeah.
So that means I've got to at least have... trying to figure out what color I want. So a 0.13 and a 0.13. Or actually, hold on.
Oh no.
You're going to need that in a second, but I want to do the other part first. You've got to have at least one person that's got 2, but you have to have at least one person that has 2. The 2 options are you could go the route where you have the first person only has 0 or 1 and the second person has 2, or you can go the route where the first person has 2 and then the second person has 0 or 1. So the numbers that are in here, the 0.13 and the 0.87, there's 2 times when that can happen. Okay, so we're going to write that part first. So 2 times 0.13 times 0.87 plus the only other option that I can have, this is the more complicated way, I will tell you. The only other option I can have is that they both have 2 plus. Right? So that number is going to be 2 plus and 2 plus, so 0.13 and 0.13. And if you work that out, you would get that that is 0.2431. Now, in the notes, I said that sometimes the better way to think about things is as the complement. It's easier. So, if I have to have at least one person that has more than one semester, what is the only thing I can't have?
None.
Okay, 2 people that don't have more than that. So what I can do actually is do 1 minus the option where they both have either 0 or 1. So 1 minus 0.87 times 0.87. And if I do that, I get 0.2431. So, personal opinion, complement is way easier. That's why I showed you the harder one first. That way you'll remember the easier one. Okay? It's a whole lot easier to do the complement of 1 minus the option that neither of them have more than 1 semester. Okay? You good over there?
Are you okay?
Do you hear something over there, or did you just inhale a candy cane? Oh, sitting right in front of it?
And she like swung at the trash can.
I can just hear them in the other room going, woo! That's what I thought she was laughing at. All right. Next example. Hello? All right. Number 5. A Pew Research poll in 2007 asked 2020, that's really confusing, U.S. adults whether fathers today were doing as good a job fathering as fathers 20 to 30 years ago. Here's how they responded. So better, 424, same, 566, worse, 950, no opinion, 80.
That's kind of rude. A lot of people were like,
I think it's accurate. If we select a respondent at random from this sample of 2020 adults, what is the probability that the selected person responded worse? So how would we find that?
Add them all together.
I would just say 950 out of
Well, add them all together is this number.
950 out of
950 over 2 something something.
950 out of 2020. And whatever that percentage is, it's 47%. So the probability that the selected person responded worse is 47%. How about what is the probability that the person responded same or better?
You add better and same together over the same number on the bottom.
So 424 plus 566 out of 2020. That's 990 over 2020. Which is 49%. I trust that y'all know how to do this on your calculator, how to type this stuff in.
This is something I can do.
That's why I'm just giving you what the percentages are. All right, so then, if we select 2 people at random from this sample, what is the probability that both think fathers are better today? So, my first question for you is, does the first person's opinion affect the second person's opinion?
No, it's independent.
They are independent. So, what do I need to do?
You need to draw a tree.
Not yet.
No, not yet. I don't even need to draw a tree for
What
this
is the
problem.
probability that
Can you
both
find
think
like
fathers
the
are better?
probability of 1 and then multiply?
25%.
424 times 424.
So 424 over 2020 times 424 over 2020. So you multiply that, which is going to give you 4.4%. So the probability that if you select two people and they both tell you that they think fathers are better is 4.4%.
That's rough.
I would have the no opinion.
Oh, Berkeley.
Berkeley.
What is the
That doesn't help.
probability that neither thinks fathers are better today?
That would be same, worse, or no opinion, right? All of them together.
Or I could do the total amount minus
That works easier.
the probability that they think fathers are better. So 2020 minus 424 all over 2020. Now, it's two people,
So it's times 2.
so I'm squaring it
Oh.
Oh.
because it's multiplied, same thing multiplied by same thing, so it's square, not times 2. Okay, that is a common mistake. I'm glad you said it.
Wait.
It's a teaching point.
Let's do a rewind. What?
Okay, you see how this one, I had two people, I multiply, so the probability of the first one doesn't affect the probability of the second one.
Yeah.
This is the probability of one person. Me squaring it makes it the probability of two people.
Not times
Because this problem says two people at random.
because times 2 wouldn't do that. Your
So this would really be 1596 over, just so you can see it. Person 1, person 2. Since they gave the same response, I can just square it, just to save writing.
Okay.
But if it would be better for you, you can write them all separate so that it's not confusing.
Yeah.
Oh, okay, wait.
You got it. You got it. It's the same thing we've been doing.
It's the
this
same
entire time.
thing as the one before it.
Yeah.
Yeah.
It's just in a different format.
Yeah.
Yeah.
It's just written.
I could have written the one before that as,
424.
Yeah. Okay.
It's just-
I could have also written it that way.
Okay, I don't know why it took me.
Just because this one has the minus sign until you actually do the subtracting.
I
it.
forgot for something to be times or multiplied by 2, it has to be like a 2. I thought.
You knew what you were saying, you just verbalized it wrong. But in your head, you had it right. Yeah, we're going to go with that.
Right in my head.
We don't need to know that.
All right, what is the probability that one person thinks fathers are better today and the other doesn't?
424 over 2020, and then the 15 times the 1596 over 2020. Correct?
So you almost are, yes, you're set up basically right, but I'm going to point out something that you probably wouldn't notice. Yeah, yes. Well, no, because that's, well, okay, yes.
What?
Okay,
It's no opinion. You have to subtract
No.
80. Oh, darn it.
Well, it's all three of them.
isn't it possible that the first person can say better and the second person can say not better, but can say any of the other options?
Yeah.
Isn't it also possible that the first person can say not better, but the second person can say better? There are two ways that it can happen.
Yeah. So it's times 2.
So this one is times 2.
Like with the actual number 2.
Yes.
Okay.
Okay. We multiply by 2
Ew, why did my tool
because there are two ways that this can happen.
You know what would be cool? If, like, when you wrote it, translated it to text.
It can.
Yeah, it can.
So you can have, like, any font you wanted on any notes, and it just automatically does that. Like, if I wanted to write my research paper,
Why would
Yeah,
need
you
three
could.
options?
I could
Handwrite
just
it.
write it out, and then it, like, words.
Yep.
Go. You're too cool.
Yeah, that's true.
We're not cool enough for you.
That's true.
So this percentage is 33.2%. Because there's only 2 people.
What assumption did you make? Assumptions are bad. They don't assume
Because
anything.
I was
That
assuming.
the most probable is that neither thinks that probably go better.
Because it's a probability that one thinks they're better and one doesn't. So one is better and then the other one is everything but better.
Oh, I see what you're saying. Okay. I thought you were saying something different, and that didn't make sense.
I really have to pee, but I'm trying to make it through the end of this.
Me too.
I drank this whole thing twice today, and I had a cup of tea this morning.
It's okay. We're almost done. Once we do F and G, we're done for today
Okay,
because
let's
the
go
bell's
back.
gonna ring. All right. What assumption did you make in computing these probabilities?
I don't assume it's bad.
The 62.4%, which is most of it, is that people don't think fathers are better.
What? We know that.
What did you make before you ever started doing the probabilities? What did we talk about at the beginning?
Independent?
Does Berkeley's opinion affect Sarah's opinion?
No.
Independent. You assume they were independent.
So we assumed probability responses are independent.
Yes, I think my assumption is reasonable because no one has the same life.
Okay, so basically, yes, that would work. Okay, why is this assumption reasonable? They were chosen at random. Okay, or we can at least assume
that
that they
it?
were chosen at random. So one person doesn't affect the other.
Is that actually it?
Yeah, I'm gonna make one more comment, but I'm gonna turn the video off first.
Can you use the restroom?